Example 2, it says find the equations of the normal to the curve y equals x minus 5 upon x minus 1 at the points 5, 0 and 1, 0. And then part B will come to later. So always start off by copying down the equation of the curve. Because this involves finding equations of normals or tangents, you are going to have to work out gradients at some stage. And remember, gradient means differentiate, find dy by dx. So I cannot differentiate this yet. So what I'm going to do is multiply out the brackets. So that's going to give us x squared minus x minus 5x, that's minus 6x, and then we're going to have plus 5. Now we're in a position shortly where we can differentiate, but also we could actually draw a quick sketch of this curve. So it's a quadratic and coefficient of x squared is positive, so it's going to be a happy shape. It's going to look something like that. And let's try and put the points on the curve. So the points are 5, 0 and 1, 0. Note that those points are also on the x-axis. So what we could do is we could rule the x-axis and we could put both points on. So 1, 0 would be further to the left, smaller x coordinate. 5, 0 would be further to the right, bigger x coordinate. That's our x-axis. So we want to get the equations of the normals to the curve at each point. So remember, the tangent at 1, 0 would just be touching the curve at this point. So the normal would be at right angles to the tangent and would cut right through the curve. So that would be your normal at 1, 0. I'm going to call that N1, normal 1. And likewise, your normal at the other point, again, would be at right angles to the tangent and would cut through the curve, and that would be your N2. And you can clearly see the two normals intersect each other, which we'll come to when we do part B. So that's a pretty good start. Before we even do anything else, we have a nice picture in our head of what the normals look like. Now, let's start with normal 1 here. Normal 1 slopes up, so we're expecting its gradient to be positive. So we'll find that out shortly. And normal 2 slopes down, so we're expecting its gradient to be negative. So we'll check those when we get to it. So what's the usual setup? Always start with the point. So let's take our first point, 1, 0. So I write down a title point, and then underneath 1, 0. So all the information I'm now doing is relevant to the point 1, 0. So you can't get the gradient of a normal until you know the gradient of the tangent at this point. So even though we're not asked about the tangent, we still need to work with the tangent. So title tangent. We're now going to get the general gradient of the tangent at any point on the curve. And that, remember, is dy by dx. So we're going to differentiate the curve. So we're going to get dy by dx. And that's going to give us 2x minus 6. And then you can forget about any number terms. So there's your general gradient of the tangent at any point. What we need to do is get the actual gradient of the tangent at 1, 0. So we're going to get actual gradient at the point where x equals 1. In other words, this point. So we chuck the x coordinate of the point into the general gradient to get the actual gradient of the tangent. So we're going to get 2 upon 1 minus 6. So 2 minus 6 is going to give us negative 4. That makes sense because if I were to put the tangent in, the tangent at 1, 0 would be sloping down, so it would have a negative gradient. So that's as far as we need to go with the tangent. We don't need to get the equation of the tangent because it didn't ask us. We're now going to switch our attention to the normal n1. So normal n1. So the actual gradient of the normal at the point where x equals 1. So we go back to the actual gradient of the tangent at that point. You flip it upside down and change its sign. So we're going to get positive a quarter. So we've now got the actual gradient of the normal, n1. And again, go back to the diagram. The normal slopes up, so we expect its gradient to be positive, and it is. So now we can get the equation for n1. The reason we can get its equation is because we know the point that it goes through. The point that it goes through is 1, 0, and we know its gradient. So it goes through 1, 0, and gradient is equal to a quarter. Label the point x1, y1, and then sub all the information into the brand new equation of a straight line. Then we're going to multiply through by 4 to clean the denominator. Multiply out your brackets. And then I'm going to move all the terms to the same side. And I'm going to leave it like that. Unless it specifically told you what form to leave it in, that's perfectly acceptable. That form is also known as the general equation. So find the general equation of the normal, or the general equation of the tangent. Means have 3 terms on one side equal to 0 on the other. You could equally bring all these terms to the other side and have another version for it. Okay, so just read the question carefully. It could also say give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. That would also be this form. So if it doesn't specify the form, then it doesn't matter what form you give it in. So that all of that work has led us to get the equation of normal n1. We now turn our attention to normal n2. So that's now relevant to the point 5, 0. So again, I'm going to start with the point 5, 0. And again, we're going to work with the tangent first. Have to get the gradient of the tangent at that point before you can work out the gradient of the normal. Now, some good news. We don't need to get the general gradient of the tangent. We've already worked that out. So we're now working out the actual gradient of the tangent at 5, 0. So we're now chucking in the x-coordinate of 5 into the general gradient. So actual gradient at x equals 5. Okay, so chuck 5 into the general gradient, so we're going to get 2 upon 5 minus 6. 2 5s are 10, minus 6 is going to give us 4. Now, that's the actual gradient of the tangent at 5, 0. So the tangent at 5, 0 would look like that, what I'm doing with my pencil, line sloping up, so it would have a positive gradient, so it makes sense. So now we're going to turn our attention to the normal, n2. And we can now get its actual gradient at the point where x equals 5. So, the actual gradient of the tangent where x equals 5 is 4, so to get the actual gradient of the normal, we flip the actual gradient of the tangent upside down and change its sign, so it's going to be negative a quarter. And that makes sense. Go to the diagram. N2 slopes down, so it's got a negative gradient, and it does, so it's all perfect. So now we're going to get the equation of normal 2. So we know that it goes through the point 50. We also know its gradient. We label our point x1, y1. And then we chuck all the information into the brand new equation of a straight line. Again, multiply through by 4 to clean any denominators. Then multiply out our brackets. And again, I'm going to bring all the terms to the same side. I'm going to bring everything over to the left. And there you go, that's a perfectly acceptable answer for the equation of the other normal. Okay, so final answer, normal n1, so that is 4y minus x plus 1 equals 0, and the other normal, n2, is 4y plus x minus 5 equals 0. Okay, so that's part A. What we're going to look at now is part B. So if we go back to the question, part B says the normals intersect at point P, find the coordinates of P. So if we go back to our diagram, it says the two normals intersect at P, so that's where P would be. So we're expecting the x coordinate of P and the y coordinate of P to be positive, so the x coordinate of P must be somewhere between 1 and 5, so that's a useful heads up. So let's look at part B. So what we're going to have to do is write down the two equations again. So the first normal, 4y minus x plus 1 equals 0. And then the other normal was 4y plus x minus 5 equals 0. And I'll just label those two equations 1 and 2. Okay, so the plan is to find a point or points where a line or curves intersect. Rearrange one of the lines to make x or y the subject and then sub it into the other. So I'm going to make x the subject of equation 1. So rearrange 1. So I'm going to make x the subject just because it's easier and you avoid fractions. So shift it over to this side. So we're going to be left with 4y plus 1 equals x. And then we're going to sub into equation 2. So replace everywhere you see x with 4y plus 1. I would also put brackets around the 4y plus 1 just on the be on the safe side before we sub it in. So we're going to get 4y plus 1 minus 5 equals 0. So we're going to get 8y, 1 minus 5 is minus 4, and that's equal to 0. So we're going to get 8y equals 4. So we're going to get y equals a half. And that's good news, because remember we said from our sketch the x coordinate and the y coordinate have to be positive. So super news, so that's y, and then we'll call that equation number 3. So I'm now going to sub that value of y back into equation 1 or 2. So we're going to sub 3 into 1 or 2. So sub it into 1 then. Everywhere we see y, replace with a half. So we're going to get 4 multiplied by a half. And then we've got minus x plus 1 equals 0. So we're going to have 2 minus x plus 1 equals 0. So 2 plus 1 is going to give us 3. And then shift x to the other side, we're going to get positive x. And that makes sense. If we go back to your sketch, the x coordinate of P, it has to be somewhere between 1 and 5, and we get 3. So that makes perfect sense. So our final answer, coordinates of P are 3, a half. And that's our answer for part B.